Megan Sabato.
And today we're going to be talking about an important topic, school bus safety. Now, how many of you have a child that goes to school right now? Raise your hands. Okay, now imagine if one day you found out that your fellow child was either struck, injured, or killed by a vehicle that did not yield or stop for the school bus. Let that sink in.
In the United States, children that ride the school bus are an increased rate of injury while getting on and off the bus because drivers are failing to yield to students who are crossing the street. About 24% of injuries involve getting on and off the school bus.
We came up with this problem statement because back in October of 2018, 4 students were struck by a vehicle going 60 miles per hour. 3 of the 4 students were killed on impact. All 3 of these kids were part of the same family, ranging from 6 to 10 years old. 2 of the students were 6 years old, twins, and the other was their sister, 9 years old. Names were Olivia, Xavier, and Mason. The other student, Matthew Lowe, was 11 years old. As he was crossing with them, he was hit, and he was put in life-threatening injuries. He had to be airlifted to the hospital nearby. He survived. Some background history on the school bus. Now, in 1990, the Betsy Bar, also known as the Betsy Gate, was created because of a girl named Bessie Anderson. She was crossing in front of the school bus, and she was 6 years old, and the school bus driver could not see her crossing, resulting in moving forward and running over her. In 1993, the rounded mirror on the left and right side of the school bus was made because bus drivers could not see the blind spots. Now, in incorporating these, they were able to see the left side and the vehicles coming through and the right side. Also on the back and the top of the school bus, there are flashing lights. The white flashing light on top of the school bus lets drivers know when the school bus is nearby at nighttime. The do not pass sign on the back of the school bus can either be on the left side or the right side. This indicates where drivers are able to see when the bus is stopped. It's also located on the left side of the school bus on the stop signs. And each school bus either has 1 stop sign or 2, depending on what model it is.
Now, in 2011, 283 people were killed in school bus related accidents. Now, in addition to that, 24,000 people were injured. In the U.S., the average time students are at their highest risk of injury is from 3 to 4 p.m., which is right around the time that all students are getting on and off the bus and going home.
Now, proposed solutions. Me and Megan, we were separated into 2 areas where we had 10 minutes to create 3 to 4 sketches. The 3 to 4 sketches were ideas that we came up with to possibly prevent or stop the students from being killed or injured from vehicles. Now, when we came together, we were able to put these ideas together and come up with the prototype that we have now. Solution matrix. The solution matrix is basically all the ideas that are on the school bus right now, all the inventions, and we put them all together in categories. These categories were able to rank from the worst to the best ideas. Doing so, we were able to see what we could incorporate into our idea and see what works the best and what works the least, allowing us to see what our best invention would be. Design criteria. If you don't know what design criteria is, it's basically a set of goals that we set for ourselves so we know what we want to present and how we're going to put it all together.
So some of the things on our list was to reduce the risk of children being injured or killed by oncoming vehicles while getting on and off the bus. Another one of our goals was to make drivers more aware that when the bus is stopped, there are kids getting off and they might be crossing the street to go home. This is our design matrix, which we considered one of our final sketches of what we wanted our final product to be. Now, this picture is, on the bottom you see a side view of our final product, and in the top left corner, a view of our back of our bus.
Solution justification. Now, we wanted to make sure that our prototype was fail-safe, it kept children safe, it was not getting away to any drivers, the bus driver, or the children crossing, and it was at zero to no learning curve. Basically, this means that if you were able to hold our prototype or even view it in action, you'll be able to tell what it means just by looking at it.
So this is where we started to actually find our solution and start building things to go with our solution. So here you see that we have a smaller version of our bus, which this bus we made so it has everything possible that a regular bus would have. So you see here that there's 2 stop signs, which is on the side here, and on the front of the bus is the Betsy bar. It also has the front mirrors and all the lights on the back of the bus.
Materials. We use MDF board, 3D printed plastic, VEX kits such as LED lights, the incorporating of the coating, robot seat, and vinyl that goes on our final product.
So here are some pictures of our final solution. So as you can see in the middle picture, there is a Betsy bar with the lights built into it. There's a green light and a red light. The green light tells them when to go and the red light tells them that it's not safe to cross.
Method of construction. So what we first had to do was do a bunch of sketching. Sketching allowed us to see our constraints of what we had to work with in the size of the school bus. The next was prototyping with cardboard. The prototype you see on the left side is our first prototype we had. We had to make sure we had a scale of the bus to see what we could work with, what goes where, and see how everything moves. Next was going to Home Depot, allowing us to create our final prototype or model of our bus. Now what this product is a version of a school bus to a 1:6 scale that allows us to see what we want and where everything should go. And so we started building with our supplies using Inventor. Using Inventor allows us to 3D print our product that will go on the front of the Betsy bar or Betsy gate, and green activating as we go for students to cross the street. The red would indicate to stop. The reason why we have red and green is because when students are crossing the street, they're going around the front of the bus. When you go around the front of the bus, this bar will go out. You cannot see on the left side of the school bus. Doing so, this works where drivers would not stop or yield for a school bus. They get struck. This is what happened in October where 13 children were killed.
So here you see are just some pictures of us actually building our final bus and also our mini bus here. The bottom picture you see all of the wiring that had to be done to the Cortex, which is the brain of the operations, which is also hooked up to the sonar sensor, which is in the back of the bus that detects if a vehicle is actually coming or if it is safe to cross.
So justification and method testing. When we wanted to see if we had a small to zero learning curve, we would ask our fellow students in the cafeteria during lunch. During lunch, we'd bring our presentations and all of our fellow members, and we would see what they would say about our product, resulting in the green light saying go, and the red light saying stop. And on the back, on the right, left side, we have our our wires that go on the back of us on the inside to show where everything goes. We have a sonar sensor on the back of the bus. We have our Cortex that allows us to do robot seat and code how the sonar sensor in the back is able to detect the vehicle, allowing the lights in the front to turn on red or green. I'll show you. Green light indicates that there's no vehicle behind it. But when you get close, it'll turn red. Now, if you back away from it, seeing that there's no vehicle there, or if it's there for a long time, it'll turn red. That's basically our idea of what we want to do for our product.
Now, we had contacted someone from Richley Vans Incorporated, and when I explained to her what our idea is and the problem we are facing, she made comments such as, wow, this is a very good idea, and most kids don't know when to cross because they can't see, and if they see their parents across the street, their parents aren't helping them, they're just excited to go home. So this is a table here of our testing results. We got kids from ages of 6 years old all the way to 17 years old. And here this just shows that it doesn't matter how old you are, they all understand that red means that